Hello and welcome to Michelle and Yasmin's IT Internship Quarter Project Report that was completed in room A134. In A134, four 7-foot tall equipment racks with brackets are attached to the wall for support, cable management. According to one website, the instructions say that it assembles in about 10 minutes using standard hand tools. Twin top angles for rigidity. It has tapped assembly holes, which eliminate the need for nuts, and it simplifies assembly and squaring. This diagram was found on TeleExpress, and they're selling this rack for $357 without shipping, without tax, that's just raw, and it's not powder coated. The cost of the network room in racks alone is estimated to be at $1,428. Each device was consoled into and all the configurations were cleared. Most devices, we could clear their configurations back to default with the right erase command. A few devices were password locked and had to be reset. And unfortunately, one was beyond help. The Raman mode startup file was corrupt, which means that the whole operating system needed to be reinstalled and configured. Due to this being outside the scope of our project, and the device was just replaced. Many devices also have VLANs configured, and they had to be removed by deleting the file with VLAN configurations and replacing it with a blank one. VLANs do not clear with the command right erase. Data was collected from each device, serial numbers, operating system versions, and configuration registrations. A few devices had TFTP socket errors, and they were noted for configuration at a later time. Again, that was outside of our scope of work. During our adventure in exploring what was going on with these devices, these are the main screens that we were interacting with. On the left, you see the VLAN, show VLAN brief, and it lets you know what VLANs are there, what ports are in. And then on the right, you can see that that's a running config showing all the different ports, gigabyte internets and interfaces, as well as you can see on the far right bottom that there's an interface VLAN is programmed in there. So we made sure those were all cleared out here. But even if you do go into the device and you say interface VLAN 10, no IP address, you'll just get a no IP address, won't be assigned to that VLAN 10. It doesn't actually erase the VLAN. You have to do that alternatively.
Alright, so the first step we've done was create a spreadsheet with all the information and status reports on our devices. So this is our previous spreadsheet. It was the spreadsheet we made when starting. As you can see, there are device tags. Device tags are the tags on the devices that were labeled on a previous round or a while ago. Device numbers are depending on where it is, on 1 to 12, because there are 12 devices each rack. Serial numbers, device location, where it was, type of device. As you can see, the highlighted with yellow is switches, and light blue would be routers. The device status, type of service needed, software operator version and config regulation. There is a bolded area on rack 3, device 5. There's 2 of them. That is because of the last one being missing an SSH. So we replaced it with a different one, which is the now cat SI.
Each device was labeled with a tag and what channel it is plugged into on the PDU. So we had rack, the number rack, lab, number of the lab, and then the device number. And that turns out to be R for rack 2, say L3, lab 3, and then dash 4 for device. And then the other tag that we did is what channel the power cable is plugged into. So we had PDU top, TOP, and then we also did abbreviated bottom, BTM, and then channel, the CHNL, and then we put the switch number 1, 2, 3, 4, 5, 6, 7, 8. And when I was configuring these, since we balanced the load, we made sure to cover the ports so that nobody's trying to plug anything else into them. They're full. The PDUs have no more room, no more amperage to give. They're already over giving. So went ahead and blocked those plugins that were empty because on rack 1, later I'll show you, we had all the top 4 devices were on the first PDU and all the bottom devices were on the second PDU, and that wasn't split evenly to the eye, but due to how the amperage worked out for those devices, and Yasmin mentions this later, there were just too much amperage. It just needed that whole PDU all to itself. So it is important to understand which one is plugged into what, and there's no tugging on cables after I configured and managed the cables. You can't just tug on them and try and sort them out that way. That would be very difficult. So having a label is going to be really handy for the newer students. As we went through our project, we were able to find more information that needed to be applied to the spreadsheet. So our first one became a draft, which made sense. And then this is our next one that we spent a lot of time with, and Yasmin's going to walk you through it.
This will be our newest Excel spreadsheet. It includes device tag, type of device, serial number, software operating the version, config regulation, device status, service needed, power ampage, and where it's powered through to on channels, and the total ampage for the power distribution unit. As you can see, the yellow highlighted rows, it's due to a socket error. We are unfortunately unable to solve it, and it is out of our scope of work. So we have highlighted it for future references for anyone that's the scope of their work and they can solve it. Our lowest ampage was 7.6, including Rack 1 Lab 2, Rack 2 Lab 1, Rack 3 Lab 1, and Rack 3 Lab 3. Our highest ampage lab was Rack 1 Lab 1 with total of 18 amps.
The Cisco switches we had on the racks we had 3560, Catalyst 1000, the 2960, and then a 2900 series. The picture on the top here is a set of Catalyst 1000 switches. Those are some of the newer ones, and most of their amperage that's on our racks is at 0.8, as Yasmin has already mentioned. The two down below, those stacks, those are 2960s, and that's the different versions. We've had the ones with the less ports and the ones with the more ports as well. And then the device on the right hand side, that's a picture of the 3560, the one random one we have. Here's some examples of the Cisco Switch 2900 series. We've got a stack of 3 on the top of their different versions and how they're configured in the front for port wise. I'm more used to seeing the back of the device, so it was a little struggle trying to find a picture with the appropriate image that had the right switch in it. And instead, I found a lot of the newer 2900 series switches, which they have an SD card place for them to put, you can put information in. So that was really cool. There's some new technology out there, and they were like half the size, a little thicker, I felt like, but I was also looking on the computer screen, so I didn't get to touch it. As Yasmin mentioned earlier, the Cisco routers that we had were the 4300 series and the 2911 series, and we'll show you a picture of these next. Here's the Cisco routers. Pictures of the 4300 series is on the left, lower left, and there's the front and the back. This device was very long and difficult to put in the rack because of the amount of weight and awkwardness that it had. This was when I was like, can somebody help me? Because if I could at least get the bottom one in, then I could use supports to help me put the next device on top. But these ones were a pain, and they absolutely needed both screws. This was very important because I could just see them leaning and falling down on the back end without the proper support. So at one point I had to move two of the racks we had. I had to move all the devices up or down some pegs to get the right holes in order to have everything be attached with two bolts. On the right hand top side, those are examples of the 2900 series, and the ones that are in the lab look almost exactly the same, if not are the same. As the racks were dismantled the first time when we started pulling devices off, many cross-threaded, stuck, and stripped bolts were discovered. About 6 devices were stuck on the rack due to a stripped and or both cross-threaded bolt or 2, and no amount of arm power would manually twist them out, not even using the screwdriver with a wrench for leverage trick. I went home and brought out the impact drill. The impact drill knocked a few loose, but I had to have screw extractors were utilized with an impact drill to remove the remaining ones. Once rack 3 and 4 were completely racked, it was discovered they were all off by a hole or 2, like I mentioned earlier, which meant every single device needed to be moved to be attached to the rack with 2 bolts. 2 bolts was very necessary due to the weight of most of the devices. Luckily, this was discovered before too much racking was done on racks 1 and 2. Quite a few of the holes were cross-threaded in the rack frames. Remember how I mentioned they were tapped? Some devices could move up or down, but others just moved up or down to another cross-threaded hole. Most of the issue was the holes were towards the start of the hole, and once past the rough spot, the bolt went in okay. So I had to back them out, pull them forward, back them out, pull them forward, and basically re-tap that beginning part of the hole in order to let the rest of it flow. I'm going to use a word I'm not really fan of, but it's crucial to exercise patience and hand set the bolts correctly. Then a low-powered screwdriver can be used to finish them up, ensuring not to strip the top in the process and hand tightening it to finish. This precision and care are a testament to responsibility and attentiveness in this task. For this purpose, I used a powered DeWalt screwdriver, me and Yasmin. It didn't have enough oomph to really tighten down the bolts so much, but one could be hand tightened afterwards. Devices and racks will be used up, swapped, dead, and changed. No one likes using a half an hour or longer just to pull out a stinking little bolt. This may seem very minute, but hand tightening the bolts allows them to be hand loosened. There were power distribution units that had one switch, and all the devices plugged in would turn on, which created a huge power drain and was very inefficient. On the left picture you see this black, it has one switch and then all of the plugs are turned on. On the right, which is what we used to what we installed and removed the old ones, installed these ones, each plug was associated with a switch, so you could turn on one device at a time manually without putting the whole entire section on power. For the power cables, there was not enough length to support a midsection power distribution unit. Each rack has now an extra power extension cord that can be managed and hidden, yet reach the wall outlet. And then we needed 8, and we ended up getting 4. So we're going to have to go back and put 4 power cables on, but at least the top PDUs are able to reach the wall outlet. When new students with little networking experience start learning how to configure devices and create networks, the racks can become a bit of a maze. Each device in the rack was strategically paired with its counterpart, with a few exceptions that were noticeably distinct, to ensure minimal confusion during the setup process. All the power cable sides were arranged in the same direction, so you wouldn't have to navigate through the tangle of power cords. This was achieved by swapping the support brackets on the devices, making the devices turn around so that all the power cords were on the same side, making it more manageable. The switches for the PDUs were facing the working side, and the outlets for the PDOs were facing the power side of the rack. Once again, just keeping all the power on one side. When installing the devices and the PDUs, the accommodating of different individuals was considered. The top was made reachable by even those of less than average height. Two switches on the top of two routers were made one lab, aka a pod. There are 3 labs per rack, so there's one high, mid, low. The configuration of each rack is standardized as much as possible, ensuring a consistent and familiar environment to help the students focus on learning without unnecessary distractions. In doing so, it was discovered that either the power amperage or the students needed to be accommodated. This leaves us with some of that overage in amperage for a few of the PDUs that Yasmin was talking about. In our next slide is the diagram that was designed and created. Yasmin put some extra special attention into this, and our next video is her giving a tour of the whole entire diagram.
Alright, so this is the diagrams of our racks. This is our diagram for one page at a time, where each rack takes up one page. We have all of their configurations, like their serial numbers. Yeah, I don't like that circle. Like their serial numbers, their software versions, and their config regulations, and their device. This all together are like simple informations. It's not really beginner things, but it's a little bit of some details of the devices they are encountering for IT211. We have all the racks to the best of our abilities of power distributing and for user friendly. We have a bunch of devices that includes device switch 3560, router 4300, switch catalog 1000, router 2911, switch 2960, switch 9200, and we have a unique one called switch 2960 SI. Switch 2960 SI is basically the same thing as switch 2960. The only difference is SI has 48 ports instead of 24 ports. We see it as not really being a big problem, since usually students even up to IT 213, so networking 3, which is still associate class, only interact with maximum to fast Ethernet 24. Usually packet tracers don't go up to 48. So even if it being a 48 port, it will still be fine, since it will just have empty or non-used ports. We do have an interesting one, which is this one, lab 2 of rack 3, which we have a 9200 and a 3560 combo instead of our normal identical devices. This is because we have a lack of even numbers, 9200 and 3560 being both odd number, so we had them paired together with 4300 routers it doesn't affect too much of the student how they what's the word, configure the devices, but it's always an interesting thing to have like two different switches in a lab to test their ability sometimes. Alright, and we can see that instead of one rack a page, some people will like all the racks in one page alone. So we have that prepared as well. We have this page where it's all just the racks. You can see all the labs clearly, and there's type of devices. As you can see, our routers, we only have two kinds. We have router 4300 and router 2911. 4300 is very much a power ampage eater. It takes about like 5 amps, while 2911 takes 3. The least ampage network device usage is Switch Catalog 1000. It takes about 0.8 ampage, but we count it as 1, rounding it up to the next number. Well, a whole number at least. And that is for the diagrams.
Here's one photo of the racks in progress. We have almost every device installed, and this is before we noticed that rack 1 and 2 had, or sorry, rack 3 and 4 had not the right level on the screw lines. On the left is a stack of my power tools, and there's a nice picture of the drill and impact drill set that I had that was extremely handy. We wouldn't be able to get away with this project without mentioning some cable management. Cable management is very important. It's best practice to keep data away from the power. One of the key reasons for maintaining proper cable management is to prevent data corruption. The electricity from power cables is not managed correctly. If it's not managed correctly, it can interfere with the data being transported through the data cables, leading to the potential data loss or corruption. Good cable management is necessary for another network engineer to come in, adjust, or troubleshoot as necessary. It lowers the chance of hazards, lowers loss of data and injury from tripping or just being confused, and the chance of mistakes and adding to human error. Each rack in A134 has the class side for power cables and the wall side for data cables. The power cables were carefully arranged to the side, and each device's power cord was added in a uniform manner, similar to French braiding technique, but without the actual braid. This method created a neat compact group of power cables along the side of the rack, with the ends tucked away inside the rack to avoid any obstructions. A hook and loop, aka Velcro, held the cables together, and each addition had a new section of hook and loop. So it was possible to remove a power cable without separating every single power cord. To be even more efficient and better practiced, the power cables should be only the length necessary to reach the PDU outlet. The power cables in this room, the current state was it was not cost effective or necessary to buy all new power cables that were the perfect length, so we used what we had. Here I have a really short video of being almost done. And when you're taking a look at these, try and guess what needs corrected here. What needs adjusted? What's wrong? So we got those mids. See how the front of the middle there, that's the 2911s. And so we had to swap those brackets. On the very top, those big long black ones, those are the 4300s. And then the white catalyst on top. And there's our power labels. Top, power, channel. So, what was wrong with the last picture? The power cables were next to the data cables. We got to keep data away from the power. So, due to a series of unfortunate events that happened so quickly, I'm not even sure what happened. The videos and pictures of the finished product were lost in the long lost data land, specifically in expansive clipboard, never to return. but the power cables did get moved from that side and were configured on the other side a lot more smoothly.
And that is where our presentation stops. Thank you for listening and thank you for your time. If you have any more suggestions, please come up to us anytime. Thank you.